In contemporary air dominance doctrines, physical maneuverability and kinematic performance have become secondary to the invisible war waged across the electromagnetic spectrum. The operational lethality of a beyond visual range air-to-air missile depends heavily on the strict secrecy of its guidance logic and radar emission profiles. When Pakistan deployed China's sophisticated PL-15E export missile during the localized aerial clashes of Operation Sindoor in May 2025, the primary objective was tactical deterrence. However, according to open-source defense reports, the subsequent failure of multiple missiles to self-destruct upon missing their targets created an unexpected intelligence opportunity for Indian technical intelligence. The catalyst for this geopolitical shift occurred when a near-intact specimen of the PL-15E was reportedly recovered in the agricultural fields of Kamahi Devi village, located deep within India's Punjab province. In modern signals intelligence, capturing a live active radar-guided missile remains an exceptionally rare event, as these platforms are engineered to fragment completely upon mission termination. Specialists from India's Defense Research and Development Organization, alongside the Indian Air Force, rapidly isolated the seeker payload. This physical access allowed technical investigators to conduct direct laboratory evaluation of China's primary export aerial threat weapon system. The core focus of the technical audit centered on the missile's miniaturized active electronically scanned array seeker architecture. An AESA seeker acts as an autonomous fire control radar compressed into a missile nose cone, utilizing independent transmit and receive modules to steer radar beams electronically within microseconds. By probing the recovered hardware, Indian scientists reportedly mapped key parameters of the weapon's frequency agility mechanisms and waveform management logic. While this does not entirely neutralize the missile's low probability of intercept characteristics, understanding these specific frequency-hopping behaviors significantly reduces the electronic unpredictability that the PL-15 family relies on. The raw electronic intelligence harvested from the PL-15E hardware was systematically translated into updated threat profiles for India's frontline fighter aircraft. Assessments suggest that the indigenous LCA Tejas and the heavily deployed Su-30 MKI fleets have received electronic warfare database upgrades, adjusting their radar warning receivers to better identify the specific electronic signature of an incoming PL-15E during its terminal activation phase. This targeted data injection improves the pilot's situational awareness, allowing defensive systems to classify threats and optimize countermeasure deployment with a substantially higher margin of confidence. Among the assets benefiting from this hardware harvest, the Indian Air Force's Rafale fleet represents a significant defensive evolution. The Rafale relies on the highly integrated SPECTRA electronic warfare suite, a system that functions through predictive algorithmic logic to jam and deceive multi-directional threats. Armed with the reported radar emissions and communication pathways of the PL-15E, SPECTRA could enable more efficient digital radio frequency memory deception techniques. By mirroring and distorting the missile's own AESA waveform, the aircraft can significantly increase its probability of breaking the missile's terminal lock. Some defense commentators hypothesize that this captured telemetry could strengthen New Delhi's hand in long-running talks over deeper SPECTRA integration, talks Paris has historically resisted, though no official linkage or software barter has been confirmed. Beyond refining aircraft defensive suites, the technical exploitation of the PL-15E is reportedly informing aspects of India's indigenous missile programs. Open-source reporting indicates that DRDO is studying the C's seeker technology and signal processing algorithms as it continues development of the domestic Astra Mark II BVR missile. By cross-referencing Chinese engineering solutions in areas such as power management and frequency agility, Indian researchers can potentially reduce certain technical uncertainties within their own indigenous program, rather than directly copying the foreign hardware. The strategic implications of the reported breakthrough extend far beyond the immediate security dynamics of South Asia drawing close attention from global intelligence communities. Defense partners within the Quad and broader Indo-Pacific framework, specifically France, Japan, Great Britain, Australia, and the United States, have reportedly expressed intense interest in examining the exploitation data. For nations preparing for potential high-intensity maritime and aerial standoffs in the Western Pacific, understanding the underlying electronic architecture of the PL-15 family is vital. However, the exact extent of any data sharing with international partners remains undisclosed, and Indian officials have not confirmed foreign access to the debris. In response to the reported intelligence compromise, official narratives from Beijing have sought to minimize the strategic fallout by emphasizing that the captured system was the export-grade PL-15E. Export variants are routinely down-spec'd, carrying a restricted engagement range of roughly 145 kilometers compared to the 200-plus kilometer domestic variants fielded internally. While Beijing stresses these differences, Western electronic warfare analysts note that core radio frequency architectures and manufacturing tolerances often share a baseline lineage, meaning Chinese military planners may still be forced to accelerate future software and hardware updates to maintain their active inventory survivability. Ultimately, the decoding of the PL-15E illustrates a fundamental truth of modern state-on-state warfare. The military balance is no longer dictated solely by weapon production volumes, but by the agility of the sensor-to-countermeasure pipeline. A singular mechanical failure or self-destruction error during a short localized operation can instantly compromise years of classified electronic development. While this intelligence gain does not completely erode China's broader quantitative and qualitative aviation advantages, it demonstrates that in the heavily contested skies of the Indo-Pacific, the platform that quickly and accurately updates its software signatures will always hold the tactical advantage.